What is Ultra Battery? Ultra Battery was first created by the Australian Commonwealth Scientific and Industrial Research Organisation. It was a unique technology that has potential in many different applications. It combined familiar aspects of lead-acid battery technology with more advanced capacitor, storage and discharge technologies to allow for better energy storage and distribution. It also has the ability to provide and absorb charge rapidly during vehicle acceleration and braking. Ultra battery technology also has application for renewable energy storage from wind and solar.
The material used for commercial ultra battery are usually made from nanostructured carbon-based materials like carbon nanotubes, porous activated carbons, or carbon aerogels. The electrolyte solution is made up of sulfuric acid and water. Plus, normal lead-acid battery operation sees small lead sulfate crystal growing on the negative electrode during discharging and then dissolving back into the electrolyte during charging. Furthermore, sponge lead and carbon layers form the negative electrode. This hybrid approach to energy storage was created to solve some of the challenges posed by wet cell lead-acid batteries and sealed lead-acid batteries.
For extra information, in the ultra battery, the positive plate of lead acid is made of lead dioxide and the negative effect plate is made of porous lead material. The ultra battery integrates the lead acid battery and supercapacitor in both the structure design and the use. The electrode are constructed of a lead grid with a lead-based active material compound, lead oxide, and forming the remainder of the positive plate.
For the electrochemical energy storage for wind energy system is to integrate the supercapacitor with a lead-acid battery in one unit cells, and the ultra battery incorporates carbon plates at the negative electrode to act as a supercapacitor hybrid electrodes, allowing fast charge acceptance compared with the conventional technology. This feature makes the lead-acid battery more suitable in hybrid vehicle applications, but could also be important for short-term wind turbine output power stabilization.
These ultra batteries generally work as a secondary batteries. This ultra battery is a hybrid energy storage device that combines a supercapacitor and a lead-acid battery in a single unit without extra and expensive electronic control. The lead-acid component comprises one positive plate and one negative plate. An asymmetric supercapacitor is formed when the lead negative plate of the lead-acid cell is replaced by a carbon-based counterpart. Since the positive plates in the lead-acid cell and asymmetric supercapacitor have a common composition, they can be integrated into one unit by internally connecting the negative plates of the battery and the supercapacitor in parallel.
The cathode is the electrodes where electricity is given out or flows out. A cathode is a negative side. It acts as an electron acceptor.
While anode is the electrode where electricity moves into, the anode is usually positive side. It acts as an electron donor.
In ultra battery, the negative electrode includes two layers of lead and carbon. The reaction occurring in the electrodes are the same as in conventional lead-acid battery. In the carbon part of the negative electrode, there are two processes. First, an electrochemical reaction of deposited lead on carbon surfaces as shown in equation 3. And second, absorption and desorption of hydrogen ions in electrical double layer, which is formed at the interface of carbon surfaces with electrolyte as shown in equation 4.
Equation 4 is not an electrochemical reaction and shows hydrogen ion transferring from a double layer to electrolyte at discharge process and vice versa. Unlike electrochemical reaction, the absorption and desorption of ion happen due to an electric field near the charged electrode and no new species formed. Hydrogen ion are 6 times faster than sulfate ion, so that it's possible to ignore the absorption and desorption of sulfate ion.
The ability of ultra batteries to be recharged is due to the reversible electrochemical process that occur throughout the charging and discharging cycles. These batteries typically use lithium-based chemistry such as lithium titanate or lithium iron phosphate. During charging, lithium ions pass through the electrolyte from the cathode to the anode. The crystal structure of graphite or lithium titanate allows for lithium ion intercalation at the anode. Intercalation or insertion is the process by which lithium plus ions are introduced between the layers of anode material.
Cathode reaction. Lithium ions are simultaneously removed from the crystal structure of cathode material such as lithium iron phosphate. The lithium ion in the cathode materials lattice are removed during discharge. The battery may discharge and charge several times. Electrolyte and ion transport. Electrolyte is a conductive material that allow ion to move more easily between anode and cathode, and it usually consists of lithium self-dissolved in organic liquid or solid polymeric and act as a medium for the movement of lithium between the anode and cathode during the charging and discharging cycle. It's also ensuring the stability and integrity of the battery system.
My name is Rachel Pitaru, that host battery number BS221105150. Today I will talk about the advantage of ultra battery. The first advantage of ultra battery is high charge rate. Ultra battery is a hybrid energy storage device. The supercapacitor can provide the high power to buffer the current and protect the lead acid battery components and prolong service life of the battery. The second advantage of ultra battery is less salvation at the negative poles. The positive plate of the lead acid cells is made of the lead dioxide, and the negative is made of porous lead materials. The ultra battery integrates the lead and acid battery and supercapacitor in both.
The first disadvantage of this battery is charging issue. If you do drain your battery, it can take a really long time to recharge it. The final 20% of the battery power can take up to 18% of the total time it takes to charge. If you plan to charge overnight, this is not big deal, but if you are in a hurry, this issue can be a real problem. Secondly, inefficient energy use. If you are trying to squeeze every ounce of energy you've caught out of your battery, you will be disappointed here as this battery wastes 18% of your total energy. For every 100 amps of power, you only store 85 amps hour.
In order to maximize the longevity of the ultra battery, the inverter or charger and the smart grid management can be used with the ultra battery. So, it is clear that the widespread use of the renewable energy system can lead to a reduction in the global consumption of the limited supplies of the fossil fuels and the associated production of greenhouse gas emissions.